Welcome back. From previous classes, we have been discussing about Newton's law of motion. Today, we will discuss Newton's third law of motion. The Newton's first and second laws of motion tell us how an applied force changes the motion. It provides with the method to determine the force. According to Newton's third law of motion, when one object exerts a force on another object, the second object instantaneously exerts a force back on the first. The two forces are always equal in magnitude but opposite in direction. These forces act on different objects and never on the same. Let us watch this video clips to understand more. In this video clips, we saw that the players collide with the players of the opposite team and both feel hurt. This is due to both the players applies a force to the other. Here, there are two opposing forces, are also known as action and reaction forces. Let us watch the examples of spring balance.
Take two similar spring balances A and B. The free end of the spring balance A is attached to the hook which is fixed in a wall. Now pull the free end of the spring balance B towards right side by hand. We see that both the spring balance show the same reading, which is 2 Newton. This is because when we pull the balance B, it exerts the force of 2 Newton on the balance A. The balance A pulls the balance B with the equal force of 2 Newton, but in opposite direction. It means balance B exerts a force of action on the balance A, and then the balance A exerts equal force of reaction on the balance B.
Therefore, Newton's third law of motion states that for every action there is an equal and opposite reaction. Let us watch the few examples for Newton's third law of motion.
In the rocket, when fuel is combusted, the rocket pushes down gas with the force of its powerful engines. This is the action. The reaction is that the gas pushes the rocket equally upwards with an equal force. While rowing a boat, the boatman pushes the water backwards with the oars. The water exerts an equal and opposite push on the boat, which makes the boat move forward. Now you must be thinking, if birds fly by action and reaction, then how do we all animals walk on this planet Earth? When we walk on the ground, our foot pushes the ground backward and the ground pushes the foot forward. The forward reaction exerted by the ground on our foot helps us to walk. The air rushes out of the balloon in the downward direction. This air pushes the balloon upwards in opposite direction to its movement. When a bullet is fired from a gun, the force sending the bullet forward is equal to the force sending the gun backward. Due to high mass of the gun, it moves backwards, and it gives backward jerk to the shoulder of the gunman. This backward motion of the gun is called the recoil of the gun.
In this example, even though action and reaction forces are equal, the acceleration of gun is much less than the acceleration of bullet. This is due to gun has greater mass than the bullet. Next we'll move on to conservation of momentum. Suppose two objects of masses MA and MB are traveling in the same direction along a straight line at different velocities UA and UB respectively, and there are no other external unbalanced forces acting on them. Let UA is greater than UB and the two balls collide with each other. This collision lasts for a time t. The ball A exerts a force FAB on ball B and the ball B exerts a force FBA on ball A. Suppose VA and VB are the velocities of the two balls A and B after the collision respectively. We know that momentum equals to mass into velocity. Therefore, the momentum of ball A before and after the collision are MA into UA and MA into VA respectively. Therefore, rate of change of its momentum FAB equals to MA into VA minus UA divided by T. In the same way, the momentum of ball B before and after collision are MB into UB and MB into VB. Therefore, rate of change of momentum FBA equals to MB into VB minus UB divided by T. According to the third law of motion, the force FAB exerted by ball A on ball B, that is action, and force FBA exerted by the ball B on ball A, that is reaction, must be equal and opposite. Therefore, FAB equals to minus FBA. Now, let us substitute the values of FAB and FBA. That is, MA into VA minus UA by T equals to minus MB into VB minus UB divided by T. By simplifying, we will get MA into UA plus MB into UB equals to MA into VA plus MB into VB. This means the sum of momenta of the two objects before collision is equal to the sum of momenta after the collision, provided there is no external unbalanced force acting on them. We'll continue in the next class. Thank you.